All right, welcome to The Explainer. Today, we are jumping right into a Java interview question that trips up a lot of developers. We're going to break this down so you're totally prepped for the big day. Let's get into it.
So, just imagine it. You're in the interview, you're nailing the questions, and then this one comes up. Now, this isn't just a trivia question. It's a test to see if you really understand why these data structures exist, and trust me, by the end of this, you are going to have a rock-solid answer.
Okay, the absolute first thing you need to get is that these two are not interchangeable. Not at all. Think of them as two completely different tools in your coding toolbox. A tree set, that's your sorted set. Its whole life, its entire purpose, is to keep a collection of unique things in perfect, sorted order, all the time. A priority queue, on the other hand, is a min heap. Its job is way more specific. Just give me the most important item, which is usually the smallest one, really fast. It couldn't care less about keeping everything else sorted.
So let's grab that first tool out of our toolbox. This is the TreeSet, your go-to for anything that absolutely has to stay sorted no matter what.
So how does it do it? Well, under the hood, a tree set is using a special kind of balanced tree, a red-black tree, to be exact. And that structure is the secret sauce. It's what lets the tree set enforce its two golden rules. 1, no duplicates allowed, and 2, everything is always in order. This makes it amazing for checking if something is in the set and for searching through it super quickly.
And the best part is just how simple it is to use. I mean, look at this code. We're adding numbers in a totally random order. 7, then 3, then 10. But when we print it out, boom, perfectly sorted. 3, 7, 10. The tree set handles all of that sorting and uniqueness work for you automatically. It just works.
So when do you actually use this thing? Well, you reach for a tree set when keeping a unique list of items sorted is your #1 priority. And because it's always sorted, you get these awesome navigation methods for free. You can ask it for the ceiling, the next item that's greater than or equal to a value, or grab a subset, like a slice of your data. And of course, checking if an item even exists in the set is lightning fast.
Okay, let's put that tool down and pick up our second one. This is the PriorityQueue, and it is a specialist designed for a very different kind of job. With the PriorityQueue, the entire game is about one thing: getting the next item efficiently. It's a min heap, which just means the smallest element is always bubbled up to the top, ready for you to grab. It is not about sorting the whole collection. It's only about making sure the most important thing is right there, on deck. Oh, and unlike a tree set, it's totally fine with duplicate elements.
Now pay close attention to this code because this is the part that gets so many people. We add the same numbers, 7, 3, 10. If we peek at the top, we get 3, the smallest one. Perfect. But, and this is the big but, if you just iterate over the queue and print it, the order is going to look like nonsense. That's because it's not in sorted order, it's in what's called heap order. The magic only happens when you pull it, when you pull elements off one by one. Then, and only then, do they come out sorted. 3, then 7, then 10.
So the use cases are completely different, right? You use a priority queue when you need to process things based on priority. Think about a task scheduler in an operating system, or a pathfinding algorithm like Dijkstra's. With Dijkstra's, you're always asking, what's the next closest node I haven't visited yet? A priority queue is perfect for that. In those scenarios, you don't care about the order of all the tasks, you just care about one thing: what's next. Okay, so we've met both of our tools, now it's time for the main event. Let's put them side by side and see how they really stack up when we talk about performance. This table right here, this is the heart of your interview answer. First, notice that adding an element is O log n for both. They're both pretty efficient there. But here's the kicker. Look at the contains operation. For a tree set, checking for an element is a super fast O log n. But for a priority queue, it's a slow, painful ON search. It has to look at every single element. Why? Because the priority queue is only optimized for one thing: finding the minimum element, which it can peek at in constant, O1 time. It's a classic example of a performance trade-off. Okay, let's take everything we've just learned and boil it down into that perfect, confident answer that's going to make you look like a star in that interview.
Here it is. This is the summary you can deliver with total confidence. You choose a tree set when you need a collection of unique items that must be sorted at all times, especially if you need to do powerful searches or navigate through it. You choose a priority queue when your main job is to pull the next highest priority item off the top over and over again as efficiently as possible.
And hey, if you really want to impress them, drop these gotchas. The #1 mistake people make, thinking you can just loop over a priority queue and get sorted elements. You can't. That's a huge one. Also, for a tree set, its sorting logic needs to agree with its equals method, or you're going to have a bad time. And finally, a good pro tip, neither of these are thread-safe out of the box. You'd need to wrap them for concurrent use.
So, at the end of the day, it's not about which one is better. That's the wrong way to think about it. It's always about choosing the right tool for the specific job you have to do. Do you need a sorted collection, or do you just need priority access? That's the real question.
And there you have it. You've just walked through one of the classic comparison questions you'll face. Now you're not just picking a data structure, you're making a strategic choice based on performance and function. So the only question left is, what's the next tool you're going to master for your toolkit?